we're going to use the fact that delta W non-conservative equals delta KE plus delta PE, and that's easily derived if you know how to split the work done by the net force. So if the work done by, the work done by the net force is the work done by conservative forces plus the work done by non-conservative forces. Okay, conservative, non-conservative, one or the other, and that includes all forces. Okay, well, work done by conservative forces is equal and opposite to change in potential energy, basic rule, basic principle, basic definition, plus the work done by non-conservative forces. Now this is all on the system. I'll probably throw those on subscripts in here if I can find room, but let's understand that these are all forces as they're exerted on the system. So that the work done by, that's the case. Work done by the net force is work done by non-conservative forces minus the change in potential energy. Work done by net force is also the change in kinetic energy. So negative change in PE plus the work done by non-conservative forces is the change in kinetic energy. So the work done by non-conservative forces is the change in kinetic plus change in potential energy. Very simple reasoning. Maybe not that easy to remember, but if you work it through a few times, you should be able to do that. Okay, we applied that to the system consisting of unbalanced masses over a light frictionless pulley. We calculated the potential energy change of each mass as the system moves 80 centimeters so that the greater mass descends. We find the changes of potential energy, very straightforward, here and here. And then we note that the system was initially at rest so that 1/2 mass times final velocity squared is equal to the change in kinetic energy. How do we get the change in kinetic energy? Well, we have the two changes in potential energy. The total change in potential energy is the sum of these, which turns out to be negative 0.4 joules. So there's your change in potential energy. Work done by non-conservative forces on the system being equal to the sum of those changes. This system has no non-conservative forces acting on it. There are tension forces, but they're acting internally to the system. There are no forces involved with a light frictionless pulley. All you're left with is gravity. So that the potential all the work done by gravity is included in your potential energy expression. And the bottom line then is that the change in kinetic plus change in potential equaling the work done by non-conservative forces on the system has to be 0, since that work is 0. So the change in kinetic and potential energies are equal and opposite. Since the change in potential energy is negative 0.4 joules, the negative here is greater in magnitude than the force here. This being negative, this being positive, gives you the difference, negative 0.4 joules of potential energy change. That's going to be equal to our change in kinetic energy. Since that is equal to 1/2 mvf squared, since we have initial velocity being at rest, that's equal to 0.4 joules. We solve for Vf, noting that the mass being accelerated is the total 20.05 kilogram mass of the entire system. We plug that in, we solve for Vf, etc. We get 0.2 meters per second, really should be plus or minus 0.2 meters per second, and which depends on what direction of the motion of the system we regard as positive. But we will get 0.2 meters per second in the direction in which the greater mass descends.